All right, let's jump right in. We're doing a deep dive into Phase I of the PMI PMMI Business Understanding. But we're not just going to walk through it like a textbook. Oh no. We're putting a project on trial. So imagine you're pitching an AI system to detect financial fraud. Before you can even think about writing code or looking at data, you have to prove your case in the court of business value. And Phase I? Well, that's the courtroom.
You heard it right. The project is officially on trial, and there's only one verdict that matters: go or no go. And this isn't about gut feelings or guesswork. It's about hard evidence. So today, we're going to build the case for our fraud detection AI using the CPMAI framework to gather the facts, present the evidence, and ultimately decide its fate. The whole point here is to make sure we're not just starting any project, but that we're starting a project that's actually worth winning.
So, here's how today's hearing's going to go down. We'll start with the Phase I map. Think of it as laying out the chain of evidence. Then, we'll look at three crucial exhibits: the performance hierarchy, some really common confusions that are classic exam traps, and the absolutely non-negotiable role of trustworthy AI. After that, you're going to face a little cross-examination to see what you've learned, and then we'll deliver the final verdict on what you absolutely have to remember.
Okay, let's get to our first piece of evidence, the map of Phase I. Now, I want you to think of this less like a random checklist and more like a logical sequence for building a really solid case. See, each task gives us a critical piece of evidence that the next one totally depends on.
So the case always starts by determining the business objective. What problem are we actually trying to solve? From there, we define what success looks like and run a cost-benefit analysis. Then, we get into what the AI has to do intellectually, the cognitive requirements, and, super importantly, the trustworthy AI requirements. After that, we identify the right AI pattern and set the performance thresholds. All of this evidence leads up to the big moment, the AI go-no-go feasibility ruling. It's only after we get a go verdict that we actually produce the final project plan. Now, just so you know, the precise order of these tasks isn't covered in the material, but this logical flow, that's the key.
And now, let's call our star witness to the stand. Exhibit A, the three-level performance hierarchy. Seriously, this is the single most important concept for judging if a project is a success or a failure. It's the framework that connects a super technical model to real, tangible business impact, and it's where a lot of projects, and let's be honest, a lot of exam takers get tripped up. So how does this thing work? Well, it's pretty clever. You use it top-down to define what success looks like, and then you use it bottom-up to actually evaluate if you got there. Let's break down the three levels. At the very top, level 1, you've got the business success criteria. This is your aspirational goal, the big win. For our fraud project, that might be something like reduce fraud write-offs by 25%. Easy enough. Then you've got level 2, the acceptable KPI performance value. This isn't the dream, this is the minimum viable floor. It's the point where the business impact is just enough to justify the cost, like reduce manual review time by 10%. And finally, at the bottom, there's level 3, the acceptable model performance value. This is purely technical. It's the floor for the model's correctness, like achieve 95% precision, and it's totally separate from the business outcome.
Now, this hierarchy gives us 4 possible verdicts when we look back at the project. First, you get a model pass and a KPI pass. That's a huge success. What you do next, well, that's not covered in the provided material. Now, what if the model fails technically? Well, that's a technical failure no matter what the KPI says. The specific action to take here is also not covered. But here it is, the big one for your exam. What happens if the model passes its technical tests, but the business KPI fails to move the needle? The most likely cause is not the model. The problem is almost always with deployment, user adoption, or a broken business process. The AI is doing its job, but the organization isn't using it the right way.
Okay, time to move on to Exhibit B. To win our case in this courtroom, our language has to be super precise. And trust me, the exam loves to trip you up with terms that sound alike but mean totally different things. So let's clear them up, rapid-fire style.
First up, objective versus success criteria. The business objective is the what, that high-level goal like reduce fraud losses. The business success criteria, that's the proof, the specific, measurable conditions that prove you actually did it, like reduce fraudulent write-offs by 25% within 6 months. And here's the exam trap. An objective stated as a solution, like implement a deep learning model, is wrong. An objective has to be a business outcome, period.
Next up, success criteria versus acceptable KPI performance values. This one is subtle, but it's so important. The success criterion is that aspirational target, the home run you're swinging for, that 25% reduction in fraud. The acceptable KPI performance value, on the other hand, is the minimum floor. It's the line in the sand where, if you fall below it, the project is a failure, even if the tech is perfect. It's the pass line, not the win line.
And that brings us right to KPI values versus model values. This is really the heart of the whole hierarchy. KPI values measure business outcomes, things like reducing manual review time. Model values measure technical correctness, like hitting 95% precision. You have to remember this: a technically perfect model that doesn't actually improve the business is, from a business perspective, a failure. They are judged on completely separate grounds.
And finally, let's talk explainability versus transparency. This is probably the most commonly confused pair when it comes to trustworthy AI. Explainability is all about a specific case. Why was this particular transaction flagged as fraud? It's reasoning at the instance level. Transparency, however, is about the system as a whole. How does our fraud detection system work in general? Are we even using AI? That's disclosure at the system level. See the difference?
Let's move on to our final piece of evidence, Exhibit C. In the court of project approval, I want you to think of trustworthy AI requirements not as some side quest or a character witness you call at the last minute. Nope. They are a core, fundamental part of your case, right from the very beginning. And they can absolutely make or break your project's feasibility.
So here are the 3 key arguments you just have to remember. First, these requirements have to be explicitly documented for this specific project. You can't just wave around a generic company policy on anti-discrimination and call it a day. It doesn't work like that. Second, these requirements directly constrain your project's feasibility. For instance, if you have a legal requirement for high explainability, you might have to use a simpler model, which could actually lower its accuracy. That's a trade-off you have to evaluate in Phase I. And finally, these requirements aren't just for show. They are formally checked during the Phase V model evaluation review process. So whatever you promise in Phase I, you better believe it's going to be verified before you can deploy.
Okay, the prosecution rests. The evidence has been presented. Now, it's your turn. It's time for the cross-examination. I'm going to hit you with 6 questions based on everything we've just covered. I'll read the question and the options, you think about it for a second, and then I'll reveal the answer and why it's right. You ready? Let's do this. Question 1. An objective is stated as, implement a deep learning classifier to automate customer support ticket routing. What's wrong with this statement? Is it A, B, C, or D? Take a second. Okay, got your answer locked in? The correct choice is B. A business objective has to state the business result the project is supposed to achieve, not how you're going to build it. This one here describes a technical solution, not a business outcome, like reduced ticket resolution time.
Question 2. Which task answers the question, why was this specific decision made for this specific case? Is it A, B, C, or D? Think it through. All right, let's see how you did. The answer is C. Required AI explainability considerations. Just remember, explainability is all about that instance-level understanding, why a single decision was made for a single case.
Question 3. A project has a strong business case, and the data is available, but the company doesn't have the machine learning engineers or the GPU infrastructure to actually build it. Which feasibility dimension fails here? Okay, the correct answer is C, execution feasibility. Execution feasibility is all about one thing. Can the organization actually deliver the project with the resources, skills, and infrastructure it has?
Question 4. Your model passes its 94% accuracy threshold, a technical win, but the business KPI shows 0 improvement. What is the most likely cause? Take a moment on this one. The answer is B. This is that classic model pass, KPI fail scenario we talked about. When the technology works, but the business doesn't get better, the problem is almost always in the deployment, the user adoption, or the business process, not the model itself.
Question 5. What is the primary difference between business success criteria and acceptable KPI performance values? Ready for the answer? It's B. Business success criteria define that aspirational target, the big win. Acceptable KPI performance values define the minimum acceptable business impact. That's the floor, the pass-fail line. And our last question. In Phase I, you analyze potential AI failure modes before the model is even built. What does this make the analysis? Is it reactive, proactive, unnecessary, or redundant? The answer is B, proactive. Phase I failure mode analysis is proactive by its very nature. The whole point is to identify potential technical, operational, and even human interaction failures before they happen so you can plan for them right from the start.
And with that, the cross-examination is complete. Let's move on to the final verdict. This is the stuff you absolutely need to commit to memory for exam day.
Think of these as the core rules and deliverables that define a winning business understanding phase.
Let's break it down into simple terms. First, the if-then rules you gotta know. If your business objective is vague, then all your Phase II data work is at risk of being a waste of time. If your stakeholders can't agree on what success looks like, then your business objective isn't clear enough and you need to go back. And if the model passes its tests, but the KPI fails, then you go investigate deployment and adoption. As for the evidence you have to produce, you need that documented business objective and its baseline, the final output from the cost-benefit analysis, the technical thresholds for the acceptable model performance values, and that evaluation readiness handoff note that gets the case ready for its final review down the line in Phase V.
So look, here's the final word. Phase I is not just some bureaucratic checkbox you have to tick. It's the entire foundation for your case. It's not about deciding to start a project. It's about building an evidence-based, rock-solid argument that you are starting a project that is actually worth winning. If you get this phase right, you've set the whole thing up for success. But if you get it wrong, well, even the most amazing AI model in the world isn't going to be able to save you.